Okay, ma'am. So this session, we are going to start with logical models. Okay, that is your second type of model which we are looking into. Okay, the first one was geometric model, and now the second one is logical models. Okay, so when I'm talking about logical models, it means we are trying to use a logical expression. Okay, logical expression for what purpose? To divide the instance space into segments, and hence we are going to construct grouping models. Okay, okay. So this is your basic concept. That is, what is a logical model? We try to use logical expressions. Okay. And what is the purpose of using logical expression? We are trying to divide the instance space into segments. Right? Okay. So now what is a logical expression? So this is an expression that returns a Boolean value. Okay. That is either a true or false outcome. Okay. So this expression will return a Boolean value that is a true or false outcome. Okay. Okay. So this is your basic thing that you should remember. Okay. And now we're stepping into the types. That is, they have two kinds of logical models, or two types of logical models. And the first one is tree models, right? Tree models. And the second one is rule models. So this logical model is converted to rules and for understandable, which is understandable for humans. That is the purpose here. Okay. We are trying to have tree models so that all the data, okay, will be understandable by any human. And the common thing that happens in rule models is these rules are organized in tree structure. Okay, tree structure or a feature tree. We sometimes call it as a feature tree. And the leaves are represented by rectangular box. Okay, and the values can be either class, real value, or probability. Okay, and if the values are class, it is termed as decision tree, right? Okay, so that is your basic, which you should understand about your tree models and your rule models. So coming to tree models, right? So I hope you all have worked on tree models like this. So what are we going to learn here? Okay, this is an example for you. Okay, so it has age, student, credit rating. Okay, so what are we trying to figure out? We are trying to figure out a student by age and also the credit rating, if it is whether excellent or fair. Okay, that is your final value is going to come under either no or yes. That is the Boolean value. Okay, so if the feature tree contains classes, okay, so this is your feature tree. Okay, and if it contains classes, they are termed as decision tree. Okay. And this is a decision tree. Why? This helps you to analyze, okay, the student, the credit rating based on the age. So it is helping you to decide something, and it is considered as a decision tree here. Okay. So we have something called features list. So how do you frame a features list? Okay, the first one is, what is your first class here? You have something called age, right? So you take up age. That is, if age is less than or equal to 30, it is taken as then then your class is going to be student. Else, okay? Else, your class is what? Your class will be taken as it is going to be yes. There is another else class where if it is greater than 40, it goes to credit rating. Okay. And if your, your bonus is greater than 40, okay, this will turn for each of it. If age is greater than or equal to 30, then class is equal to student, right? And then you are going to frame another, like if your age is equal to 30.40, your class is yes. And again, if your age is greater than 40, then your class will be credit rating. Okay. So that is how we are trying to segregate it. Okay. And each class will give you the result as a Boolean value. Okay. So this is how your tree models work. Okay. I know very well that you have talked to decision trees and all that earlier, but you are supposed to understand how your models or your tree models will work in your machine learning. Okay. And your next example is this. Here, okay, you have an example where you have all these decision nodes, terminal nodes, okay, and all this you have also your root node, okay. So what does this summarize? Okay, example, we have like different tree models, right? Decision trees, random forest, and we also have gradient boosting, which like these are some of the tree models. So the if part here, okay, so what does it provide you? It defines a segment and you have a if part and a then part, okay? If part and a then part. So what does this if part do? This will define a segment, okay? This will define a segment and the then part, this will define the behavior. By defining the segment and the behavior, you will be able to understand what type of model you are working with, okay? And this is another set of models, right? That is when a data is given to you, that is, for example, like this observation for the last 10 days of weather, okay? So you have all this and all this is converted here into a tree model, okay? So why is this? So what is the purpose of this? They are trying to decide upon an activity on a particular day, okay? So this is how a decision tree is created. They have all the data set is given and using that, they are trying to decide their motive. And here you have another set of tree models. Okay. This is another example where to decide upon to accept the job offer or not. Okay. That is the class here is okay. It is pretty much understandable. Okay. And the reason for showing you all this example is this is how it works. And this is how you are trying to define or make it simpler for a human to decide the yes or no decisions. Okay. If it is unpredictable by a human, then these decision trees or tree models are used to identify a proper outcome. That is the purpose of your tree models. And here you also have something called concept learning. Okay, so what is this concept learning? So that is something like learning logical expressions or concepts from examples. For example, you have an example of data here. So what are we trying to do? We are trying to infer a general function from specific training examples. Okay, that is called concept learning. Okay, so what is concept learning for you? Learning logical expressions or concepts from examples. Okay. Okay. So where is this used in? As simple as it is. Okay. Your tree-based models are as simple as they are. So where are they used in? These tree models will help you to give a good representation and understanding of what you've done with the data set. Okay, probably you have a data set, you can clearly explain, okay, it's all in a table. And when you're able to show it in a tree model, you will help them to understand, okay, you will help them to understand the outcome that is required and how you have acquired the certain outcome. Okay, how has the system gone for this particular decision? Okay, this representation and working will help any human to understand it in a very simpler manner. Okay,